There are a lot of misconceptions about machine learning, so here are 5 facts that will help you get a better impression of what machine learning is really about. Number 1. Machine learning is not a silver bullet or a wonder weapon. We only employ machine learning if there is no other way of solving a problem. That means we don't have a classical algorithm to solve our problem. But for sure, there are a lot of important use cases where there is no other way than using machine learning. For instance, if I show you an image, you will directly recognize that there's an elephant on it. But how to make a computer recognize that there's an elephant on this image? And not only how to make it recognize this specific elephant, but any elephant on any image. This is a very difficult problem, and so far nobody has been able to figure out the rules to write a classical algorithm that performs this task on a satisfying level. Here's where we need machine learning, and the computer has to figure out on its own which patterns are important to remember so that it will recognize that there's an elephant, a mouse or whatever on this image. And the same is true for speech recognition and language processing. Also here we have not been able to write down rules to recognize speech or interpret language. Number 2, machine learning systems are based on statistics. That means the output is always a probability. With a probability of 90%, this is an elephant. But this also means the system can be 95% sure that there's an elephant on the image, but it can still be 100% wrong, because it's a mouse or whatever on this image. Let's look at the core idea of machine learning. In our example, our data set represents the price of an apartment in relation to its size. Now you can go into a spreadsheet like Excel and let the system draw a straight line through your data. You probably all have done this before. It's a relatively simple mathematical algorithm that minimizes the average distance between the data point and this straight line. What you have done is you have fit a model to your data. And this allows you to make now predictions. What you can do is you take an apartment that is not in the data set, you take the size and predict the price of this apartment. The core concept of machine learning is always the same. You have data and then you take a model and fit the model to this data. And in real scenarios, this is not only one parameter as in our example, but there are thousands or millions of them. Still, the mathematics behind it is basically the same. And as this is a statistical approach, you always have to live with uncertainty. But the quality of the system is determined by 3 major factors. Number 1 is the overall learning process and how long you train the system. Number 2 is the quality of the model. For instance, we have used a very simple model to reflect the price of an apartment. But for sure, the price of an apartment does not depend only on the size, but also, for instance, on its location. It's a difference whether the apartment is downtown Manhattan or somewhere in a rural area. But right now, our model does not reflect this. So this will lead to completely wrong predictions on the price of apartments. And the third aspect is the quality of the data. What's not in the data, it's not there for the system. For instance, if you want to train a system to recognize fruit, you have images of apples, bananas, pears, peaches, and so on. But you don't have images of plums. Now you train the system and at the end you show it a plum. But the system has never seen a plum before, so it will predict that's a banana, an apple or whatever, but not a plum. Number 3. Machine learning systems completely depend on human decisions. There's the notion that a computer system is more objective than a human, but in the case of machine learning it's wrong. First of all, the machine doesn't decide on its own which task to solve, it's a human. The human defines the task, selects the data, selects the machine learning algorithm and model, and finally, the human defines the trust level. Again, machine learning systems are statistical systems and you only get a probability output. So a human has to decide which probability level is sufficient to accept a result as being true. So if the system is 90% sure that there's an elephant on this image, is this sufficient or not? This might be not so important in case of an elephant, but if you think about deciding whether a person has cancer or not, this decision becomes crucial. Number 4. Machine learning systems do not understand. First of all, the systems have no clue that they do image recognition or playing Go or whatever. But what do I mean by understand? Here's an example. If I give you the word donut, You directly imagine a donut in your head and you have a lot of information about what a donut is. You know it's made of dough, it's baked, it has a certain texture, a certain taste, a certain size and shape, maybe a certain color and frosting and all these things. And for sure you can imagine different types of donuts in your head. So all these bits and pieces of information are connected to the word donut in your brain. But if I talk about understanding, I mean you can use this information, you have built up knowledge to judge on certain statements, and this is called common sense. For instance, if I give you the statement, I ate 100 donuts this morning for breakfast, you are pretty sure that this statement is false, because you know the size of a donut and its calories, and it's very improbable that a human being is able to eat 100 donuts for breakfast. But if I tell you there's a galaxy far, far away where there are magic donuts that give you access to the Force, you know it's not reality, it's fiction, but still you can imagine, okay, it's part of a certain story. And all of this is called common sense, and none of the machine learning systems today are capable of doing anything the like. And so far, nobody has a real clue to get a machine doing this kind of common sense reasoning. And number 5. Machine learning systems are highly inefficient. They require a lot of data and a lot of energy to learn anything. For instance, in most machine learning projects, 90 to 95% of the time and effort go into preparing the data, and it's human effort that you have to spend. And it's about gathering the data, cleaning the data, labeling data, and so on. The pure learning time is relatively short compared to all this effort you spend there. And to give you some impression on the amount of data and compute power you require for machine learning, here's an example. Last year, a machine learning system developed by OpenAI was able to beat world-class players in the computer game of Dota 2. This was an impressive accomplishment, no question. But look at the numbers. The system required 128,000 CPUs, 256 GPUs, and 10,000 years of gameplay time. This is a lot of compute power and data. The best players maybe have spent about 10,000 hours on playing Dota 2 compared to 10,000 years. So it's a huge difference. So hope you enjoyed it and learned something. If so, give me a thumb up and consider subscribing to my channel, then you will not miss out on my next adventure.